In this video, we will do three examples of solving Bernoulli differential equation with the correct substitution. So yeah, what is a Bernoulli differential equation? It's usually in this form. It's very similar to separable differential equation. There's just one thing that's added, this y raised to the n, right? So if it's in the form of this, dy over dx plus p of x of y equals q of x times y raised to the n, that's how you know you're going to deal with Bernoulli differential equations. So the Bernoulli equation is a differential equation where n is any real number. By substituting u equals y raised to the 1 minus n, it reduces the Bernoulli equation to a linear differential equation. What are the steps for solving Bernoulli equations? Step one, make sure you put it in the correct form. If you cannot put it in the correct form, you can't use this form. You can't use this. You can't use Bernoulli. So it has to be in the form of dy over dx plus p of x times y equals q of x times y raised to the n. Step two, divide each term by the y subscript y raised to the n. So basically, whatever this number is, or whatever that is, divide each term by y to the n. Step three, substitute u with y raised to the 1 minus n and du into an equation to make it a linear differential equation. Okay. Step four, follow the steps of solving linear first order differential equation and resubstitute for u at the end. Okay, so let's start with example one. Example one says solve the Bernoulli equation. We have x times dy dx plus y equals x squared times y squared. So step one, is it in the correct form? So put it in the correct form. So is it in the form of dy over dx plus p of x times y equals q of x times y raised to the n? I think it is, right? Wait, no, it's not. What do we have to do? It's not, we have to get rid of this x. If we got rid of that x, then we'll be in the correct form. So how do we get rid of that x? We're going to divide everything by x, right? So let me rewrite the problem down here. And then just divide everything by x. So divide this by x, x, and x. And now you got dy over dx plus y over x equals x squared over x is x y squared. Okay. Now we have it in the correct form. Or you know what? This y over x, let me rewrite it to make it easier. Let's rewrite it as 1 over x times y, right? That'll make it so much easier. Okay. But now we have it in the correct form. We have our p of x, and we know our q of x, and we know our yn, right? So maybe if we write out everything. So our p of x is 1 over x. My q of x is x. And then my yn is y squared. Okay, now step two, it says divide each term by yn. So divide everything by yn. Okay, So as you can see, as you can tell, our y of n is y squared. It's going to be dy over dx over yn, which is y squared, plus 1 over x times y over yn, which is y squared, equals x y squared over y squared. Okay. Well, I guess this cancels, right? And then you see this y squared on the bottom, let's rewrite it as a negative power. So that could also be expressed as y to the negative 2 dy dx plus, you see this y squared on the bottom? Well, no. You have this y1 over y squared, that's y to the negative 1, or what, that gives you, yeah, y to the negative 1. So that's going to be 1 over x times y to the negative 1. And then you see that the y's cancel, so this is x. Okay, so we did that. Now we have this. Now what is step 3? You're going to substitute u of y to the negative 1. Right? So step 3, substitute u equals y to the negative 1 and du dx equals 2. So what is the derivative? Du dx is basically the derivative of u. So what is the derivative of that? That's negative 1 y to the negative 2. And if you want, what we're going to do next is, whoops. So yeah, you're going to replace that with, what am I going to replace 1 over x with? I'm going to replace 1 over x, or no, I'm going to replace y to the negative 1 with u. So this is going to be 1 over x times u equals. Okay, so now you have du dx plus negative 1 over x u, and then this is going to be negative x. Okay, now we have it in the form of a linear first order differential. So right here, this whole thing is in the form of a linear my pencil, there we go. Linear first okay. So now we got to find our mu, right? Oh, here we are. Okay. Okay, here we are. So your mu is e raised to the p of x d of x, and my p of x was, or is, negative 1 over x. Okay, so it's going to be mu equals e integral of negative 1 over x dx. And we know how to take the integral of negative, we do know how to take the integral of negative 1 over x dx, right? This negative is a constant, so put that in front. And then integral of 1 over x dx. What is the integral of 1 over x dx? It's just ln of absolute value of x, and then you have this minus. Okay. So you have mu equals e, and then an integral of negative 1 over x dx is negative ln The absolute value of x is just positive x. So I don't have to put the absolute value. I'm not going to put that absolute value. Can we cancel the e and the ln? Not yet, right? What you have this minus in front or this coefficient of a -1. So what do we do when you have a negative in front of the log or natural log? It just means your power, right? So this is going to be mu equals e ln of x to the -1, right? Now you may cancel the e and the ln, so you're left with mu equals x to the -1 or 1 over x, right? Okay, so we found our mu. Step 4 is multiply everything by mu. Okay, so it's going to be du dx plus -1 over x of u equals to -x. So you're going to multiply everything by mu. So this would be 1. So our mu is 1 over x. So it's going to be 1 over x du dx plus 1 over x times -1 over x u equals to 1 over x times -x. Okay. Then what you have to do is verify you have the product, the left side is the product rule of 1 over x times u prime. So this is a perfect way to make sure you didn't make a mistake. So you got to verify you have a product rule of 1 over x times u prime, right? So this has to equal to the left. So how do you take the derivative of this? You use a product rule. So what is the product rule? It should be f prime of g plus g prime of f. My f is 1 over x. My f prime is -x to the -2, or -1 over x squared. My g is u. My g prime is du dx. Okay, so let's see, f prime of g plus g prime of f, does that, yeah, I think so. That would be, so my f prime is -1 over x squared times g, which is u, plus g prime, which is du dx. And then my f is 1 over x. Yep, it does definitely look like this, just this is in front, right? That's the same order as this. It's the same thing as this. So we have verified it. Once we do that, then we just take the integral of each side. So on the left side, it's the integral of 1 over x u prime. And then on the right side, if you simplify this, 1 over x times -x is just -1. Okay. And we know that the integral and the antiderivative cancel, so you're just left with 1 over x du. And the integration of -1 is -x plus c. We don't have an initial condition, so now what we have to do is let's try to get u by itself, then we can substitute it back. So let's get u by itself, so I'm going to multiply everything by x. So this is going to be u equals x times, this is not a mu, this is a u. X times -x is -x squared, plus c times x is cx. So if u equals y to the negative 1, that means y to the negative 1 is equal to negative x squared plus the x. And then what you want to do is y to the negative 1 is 1 over y. And then cross multiply. So when you cross multiply, you're going to get y equals 1 over negative x squared plus the x. There's your final answer. We don't have an initial condition, so we'll just leave C as it is. Okay, so that was example 1. We have 2 more examples to go. Okay, let's move on to example 2. So example 2 says solve the Bernoulli equation, x times dy dx minus parentheses 1 plus x times y equals x times y squared. So step 1 is we got to make sure we are in the correct form. So put it in the correct form. So we have to somehow make it like this. Okay, so no, let me rewrite this problem. What do we have to do to put it in this form? We have to get rid of that x. So let me write it down here. Yeah, let's get rid of that x. So we're going to divide everything by x. You get dy dx minus 1 plus x y over x equals y squared. Okay, step 2, you're going to divide everything by yn. So what is our yn? It is, so there's a 1 here, and then our yn, I believe, is y squared. So my yn is y squared. So it's going to be 1 over y squared dy dx minus 1 plus x over x y over y squared equals 1. Or when you do divide y squared by y squared gives you 1. So I divide everything by yn or y squared. So let me clean this up. So 1 over y squared is the same thing as y to the negative 2, right? dy dx minus 1 plus x over x times y over y squared. That's the same, but what's y divided by y squared? That's y to the negative 1. So let me put that up front. It's going to be 1 plus x over x times y to the negative 1. And then what's y squared over y squared? 1. Okay. So step 3, let mu, or I mean not mu, u equals y to the negative 1. So step 3, let u equals y to the negative 1. So my du dx is negative y to the negative 2 dy dx. Now, you see this minus? We could put that minus in front of the du dx if you like. So you could say negative du dx is positive y to the negative 2 dy dx. Okay. Okay, so now what we're going to do is substitute. Right, we can replace, what can we do? So we can replace y to the negative 2 dy. So if you go back to this step, you can replace this whole thing with negative du dx. And then you can replace y to the negative 1 with u, because we want to put it in a linear differential equation, right? So that's what we're going to do. So this is going to now become du dx plus 1 plus x over x times it by u. And then the right becomes positive 1. Whoops. Do you see the mistake? There should be a minus right here. Okay. So all I did was I replaced this with this, and then I replaced y to the negative 1 with u. That's all I did. What would I do next? Maybe get rid of this negative by dividing everything by negative 1. Okay. So now we have positive du dx, and then 1 plus x, it's like a complex fraction. 1 plus x over x divided by negative 1. Well, actually, there was a minus right here, right? That was part of the problem, and a minus and a minus is positive, and now you're just left with plus 1 plus x over x times u. And then 1 divided by negative 1 is negative 1. Now we have it in the correct linear differential form. Okay. And we got next, we're going to find your mu. So what is our p of x? Let's just find that out. Your p of x is this whole thing, 1 plus x over x, right? 1 plus x over x. Okay, so my mu is going to be e to the integral of p of x, which is 1 plus x over x. If you clean that up, I should have cleaned that up. 1 plus x over x is the same thing as 1 over x plus 1. I think that would be a lot easier. Okay, and what is the integral? This one's easy. The integral of 1 over x is ln of x. The integral of 1 is x. So now you have mu equals e to the ln of x plus x. And then we can simplify this. E raised to the ln of x plus x is the same thing as e to the ln of x times e to the x. And yeah, so the e and the ln cancels, and then this e to the x is the same. So your mu is going to be x times e to the x, right? This e and l cancels, you're just left with x, and then this e to the x stays the same. Okay, so our mu is that. So step 4 is solve ordinary differential equation. So you remember you multiply, so let me write. Solve linear ordinary linear ordinary differential equation, right? So basically you're multiplying everything by mu, right? So this is going to be x times e to the x times du dx plus mu of 1 plus x. So it's going to be, so yeah, so go back to here and multiply everything by mu. And you're going to get, so this is going to be x e to the x times 1 plus x plus 1 of u equals x e to the x times -1. Okay, then what you have to do is on this side, verify this is the product rule. Verify it's the product rule of x e to the x times u derivative, right? So how do we find the derivative of these things? It would be the product rule. So my f is x to the ex, and then my g is u. So my f prime is, when you take the, you have to take the product rule again, so that would be x e to the x plus e to the x, right? And then my g prime is du dx. And then the product rule is f prime of g plus g prime of f. So my f prime is x e to the x plus e to the x times g, which is u, plus g prime, which is du dx. And then my f is x e to the x. So does this equal to this? I believe so. Yes. Yes, it does. So basically, if you FOIL this out, xex by this, you're going to get this. So we have verified. That means we did not make a mistake. So the next step is like pick the integral of each side. So the integral on the left is the integral of the derivative of x e to the x u. And then on the right side, it's the integral of, this is a minus, so you can put that in front of x e to the x dx. Okay, so over here, this is easy. The integration and the antiderivative cancels out, so you're just left with x e x u. Over here, how do you take the integration of x times ex dx? Can we do substitution? No, because if you set u as x, you still have this extra x. So we can't do substitution. Since there are two things that are multiplying, we can try integration by parts, right? So we could use Leite or Ilate, it's the same thing. So do we have an inverse? No. Do we have a log? No. Do we have an algebra? Yes, we do. So our u is going to be x, and then my dv is like the leftover, which is ex dx. So what is du? That would be 1 over x. And then my v is going to be the integration of ex dx, which is basically the integration of e to the x is e to the x. So if you recall, the integration by parts is uv minus the integration of v du. Okay. So my u is x, my v is e to the x, minus my integration of v du. So the integration of v is e to the x, and then my du is I made a mistake here. What du is, what's the derivative of x? 1 dx. Sorry. So du is just dx. So this is going to be x dx minus, what is the integration of e to the x? It is just negative. Well, the integration of e to the x dx is e to the x, and then you have a minus, so it's minus e to the x. And then don't forget the plus d. And then on the left, it's easy. It's just x exu. Okay. Then what you want to do is solve for u. So you're going to divide everything by x ex. So this cancels. Now you're left with u equals 1 minus 1 over x plus c over x e to the x. What could we do? Maybe we can, let's rewrite, let's not make it as a fraction. Let's rewrite this problem as u equals 1 minus 1 over x is the same thing as x to the negative 1 plus c, and then 1 over x is the same thing as x to the negative 1. 1 over e to the x is the same thing as e to the negative x. Now you can substitute u equals y to the negative 1. So yeah, let's substitute that. So this is going to be y to the negative 1 equals 1 minus x to the negative 1 plus c x to the negative 1 e to the negative x. And if you simplify this, if you try to get y by itself, y to the negative 1 is 1 over y, and then you would cross multiply that out, you should get y equals 1 over this whole thing. 1 minus x to the negative 1 plus c x to the negative 1 e to the negative x. Okay, so that's my final answer. Okay, let's do one more example, example 3. Okay, so example 3 says solve the Bernoulli equation of y prime plus 4 over xy equals x cubed times y squared. This time they give us an initial condition of y2 equals 1, or your x coordinate is 2 and your y coordinate is 1, where x must be greater than 0 or positive. So step 1, put it in the correct form. Is it in the form of dy dx? It is. If you see this y prime, that's the same thing as dy dx. And then, so it's going to be dy dx plus my p of x, I think it's going to be 4 over x. And then it's qx times y to the n. So my q of x is x3, and then my yn is y squared. Okay, so my yn is definitely y squared. Okay, step 2, divide everything by yn. So divide everything by yn. So my yn is y squared. So it's going to be 1 over y squared dy dx plus 4 over x y divided by y squared equals to x cubed y squared over y2. Clean this up a bit. 1 over y squared is the same thing as y to the negative 2 dy dx plus y over y squared, that's y to the negative 1. So that's 4 over x times y to the negative 1. And then x cubed y squared over y squared, the y squares cancel, so you're left with x cubed, right? Okay, step 3, set your u. So your u is y to the negative 1. So my du dx is negative y to the negative 2 dy dx. Now, if you want, you could put this minus in front of the du dx, so that's going to be negative du dx equals to positive y to the negative 2 dy dx. Then you may substitute, so you're going to substitute y negative 2 dy dx with negative du dx. Then you're going to substitute y to the negative 1 with u. Okay? So it's going to be negative du dx plus 4 over x of u equals to x3. Then what I would do is get rid of this negative in front of here, so you're going to divide everything by negative 1. You get du dx plus negative 4 over x u equals to negative x3. And then this is a linear differential equation. Okay, next I would find my mu, and first I got to think, what is my p of x? My p of x is this, negative 4 over x. Go ahead and find your mu. So your mu is mu is e raised to the integral of p of x, which is negative 4 over x d of x. And what is the integration of negative 4 over x d of x? That's easy, right? Negative 4 is a constant. So that's going to be negative 4 ln of absolute value of x. So it's going to be mu equals e ln of x to the negative 4. And then e and the ln cancels, so you're left with mu equals x to the negative 4. Okay, step 4, solve the differential equation. You're going to multiply everything by mu. So it's going to be x to the negative 4 times du dx plus x to the negative 4 times negative 4 over x times u, and then this is going to be x to the negative 4 times negative x to the third. Now we got to verify this whole thing is the product rule of, you got to verify this is the product rule of x to the negative 4 u prime. So my f and my g is, my f is x to the negative 4. My f prime is negative 4x to the negative 5. My g is u. My g prime is du dx. So if you do the product rule f prime plus g prime of f, that gives you, what does it give you? X to the negative 4 du dx plus u times negative 4x to the negative 5. So yes, this, if you simplify this, it's eventually going to look like this. So we verified it. So now we just take the integral of both sides. So the integral of the left is the integral of x to the negative 4 u prime equals the integral of, on the right, if you x to the negative 4 times negative x to the 3, that simplifies as negative x to the negative 1 of d of x. If you want, you may put the minus in front of the integral, and then x to the negative 1 is 1 over x dx. This one's easy. The left, the integral and the antiderivative cancel, so you're left with x to the negative 4u. The right, this is easy, right? The integration of 1 over x is the ln of absolute value of x. And then you have a minus right here. Okay, what else do I, oh, don't forget on the right, we have a plus c. Then what I would do is substitute u equals y to the negative 1. Okay, so it's going to be x to the negative 4 and then replace u with y to the negative 1 equals negative ln of absolute value of x plus c. And then you can simplify this. Y to the negative 1 is 1 over y. And then x to the negative 4 is 1 over x to the 4th equals minus ln. And then absolute value of x is positive, so I'm just going to leave it as parentheses plus c. Now, we do have an initial condition. So our initial condition was an x value of 2 and a y value of 1. So we're going to find our c by plugging in our x and y coordinates. So it's going to be 1 over x, which is 2 to the 4th, and then y is 1 equals negative ln of x, which is 2 plus c. So on this 1 over 2/4 times 1, that's 1 over 16 equals negative ln of 2 plus c. And then if you try to solve for c, it's going to be c equals ln of 2 plus 1 over 16. So you put that back to the original equation, like if you put it back here, 1 over x to the 4th, y to the negative 1, so that would be 1 over x to the 4th, y equals negative ln of x plus your c, which is plus, let me put this in parentheses, ln of 2 plus 1 over 16. And then you want to try to get y by itself, so you would have to cross multiply. So that would be, so when you cross multiply and solve for y, you're going to get y equals 1 over x 4th parentheses negative ln of x plus ln of 2 plus 1 over 16. And here's your final answer. Okay, well, we'll stop here.